Ladies and gentlemen, dear friends, dear colleagues, I'm very glad to open this session. I will be your host for today. I have the pleasure to have nice speakers and esteemed colleagues who have come here to share with us their information and their thoughts with respect to achieving marine and coastal resilience in the context of climate change, challenges and solutions. This is a side event that has two parts. I'm going to start immediately with the first part, which is entitled Addressing Impacts of Climate Change on the Marine Environment. This is organized by the Hellenic Center for Marine Research and co-hosted by the Ocean Acidification Alliance and UNEP MAP project. So to get you into the concept, I will use a few slides for a brief introduction on climate change and its potential impacts on the marine environment. So there is a causal chain. We have emissions of gases, eventually greenhouse gases, that lead up to warming. If you take a look at the lower left panel, you will see that since the beginning of the 20th century and more intensified after the second half of the 20th century, after the Second World War, we have great acceleration in the emissions of CO2, methane, and other minor greenhouse gases, which continue, of course, to rise. And this has altered the situation in the atmosphere. And you see on the other panel, on the top left side, you can see the concentrations of gases like CO2 and methane that have increased to unprecedented levels. And the problem, dear friend, is that it's all the same. It doesn't matter if you are in Crete at Finokalia meteorological station, which is maintained by the University of Crete, or in Mauna Loa in Hawaii. They all measure the same things. So it's a global problem, and you can see the variability of CO2 concentration in the atmosphere for the last 20 years or so. Unfortunately, we are kept in a constant increasing trend. And of course, we have the greenhouse effect. You can imagine that the atmosphere of the Earth behaves like a greenhouse, which means that due to the extra gases that are in the atmosphere, the heat that enters from the sun is somehow trapped into the atmosphere and increases overall the temperature. And we have global temperature increase at the surface of the planet. In the left panel, you see that in the period, the reference period, which is from 1850 to 1900, there is a smooth horizontal line with respect to temperature anomaly. And if you move to the latest decades, you have an apparent increase of temperature, which in that estimate is 1.1 degrees Celsius for the last 20 years or so. However, if you go into the webpage of Copernicus, this beautiful information system supported by the European Commission, you will see that last February, we had an average temperature of the planet at 1.27 degrees. That is to say, okay, some claim that 23 was a peculiar year, but anyway, this model of Copernicus estimates that if we follow that trend, in less than 10 years from now, in August 2033, we are going to reach the hard limit set by the Paris Convention that wishes to keep the warming of the planet below 1.5 degrees. 9 years, my friends, is very, very close. And of course, since we are talking about the sea, we are at an ocean conference. Let's see what is the side effect at the sea surface temperature. On the upper panel, you can see what is happening at the temperature in the last 30 years. Besides the ups and downs, you can see that there is a clear ascending trend. And for us who are living around the Mediterranean, things are much more complicated. You see the global ocean, of course, it warms up as a whole, but the Mediterranean warms up in a higher pace, even worse than us. Of course, the impacts are many. I could fill up several slides. I try to keep them minimum, and I give you 6 of them. Okay, warming. Warming is the most common, well-understood and well-measured parameter that we all understand, and everybody knows that the temperature of the planet is warming up, including the sea. Acidification. When you put extra CO2 in the water of the sea, the chemistry changes. You have a change in pH, which acidifies, it behaves a little bit acidic and attacks all calcifying organisms. Sea level rise. ices at the ice caps and the glaciers are melting. The water is expanding due to thermal reasons, and overall you have sea level rise, which is attacking all the low-level coastal areas. When it comes to biodiversity, we have been experiencing shifts and loss. Things are changing rapidly in the biosphere with unknown, let's say, results. There is a model that predicts that in 30 years from now, the Gulf Stream will shut down. I cannot even imagine what will happen if this is a real scenario, okay? But nevertheless, changing of the circulation of the sea due to climate change is apparent. And, of course, weather events. We experience more and more often heat waves, we experience hurricanes, we experience medicanes. I didn't know about medicanes a few years ago, but now it is a reality. It happened. We had the Anos a couple of years ago, a catastrophic event. I can go on for several hours talking about all these very, very important issues. Each one has its own science behind it. You can never stop discussing and analyzing the data. But the message, my friends, is clear. We are at a very critical situation, and conferences like this disseminate the information, inform the people, the politicians and the stakeholders, and set an alarm that rings very, very strongly that we should do something for the ocean. So I will stop here. Thank you. And we'll continue with the first discussion on ocean warming, eutrophication, harmful algal blooms, not by Tatiana Hema, but by my friend Christos Ioakimidis, who is representing UNEP-MAP in this gathering. You can have the stand, or you can sit whatever you want. It's up to you. No, don't worry about me. Take it. Enjoy.
Thank you very much. Thank you very much for the invitation. I would like also to extend Tatiana's apologies for not being able to attend this side event as initially projected. And I will make an effort to fulfill this gap. We will present some information about ocean warming, eutrophication, and harmful algal blooms, mainly coming from the MEDEC, which is the Mediterranean experts on climate and environment change, and as well as from the recent 2023 Mediterranean Quality Status Reports and the relevant results. So we have the Mediterranean Sea warming trends. This information comes from MEDEC. We have recently increased temperature between 0.3 to 0.4 degrees per decade, stronger warmings in Eastern Basin, Adriatic, Aegean, Levantine, and with some marine heat waves that become stronger and longer in terms of, as well as of intensity. The projections also are not good in the sense that we expected an increase of 0.6 up to 1.3 degrees by the mid-21st century and 2.7 up to 3.8 degrees until the end of the 21st century. Marine heat waves also will increase in their spatial extent, so they will be visible and evident in more places, will become longer and more intense. And between 2021 and 2050, it is expected that marine heat wave frequencies will increase by a factor of 1.5, with a duration of a factor of 2.4 to 2.7, and with a mean intensity of 1.5. Whereas by 2100, models project at least one long-lasting marine heat wave occurring every year. Eutrophication comes mainly from nitrogen and phosphorus. There are many sources. There are certainly more experts in this room to describe this, which lead to the harmful algal blooms. Whereas before the 1980s, the harmful algal blooms were barely documented, whereas since then, this evidence, this cases have become more frequent. In what we do in UNEPAP Barcelona Convention System, we have the Integrated Monitoring and Assessment Program for the Mediterranean Sea Coast, which is established since 2016. It is a regional framework for monitoring and assessment. Includes 11 ecological objectives, the equivalent of the descriptors, and ecological objective 5 focuses on eutrophication, mainly with 2 common indicators, common indicator 13 focusing on key nutrients, key nutrient concentrations in water column, and common indicator 14 focusing on chlorophyll A concentrations in the water column. Together with the IMAP, of course, we have progressed in the sense of having just targets, just operational targets, a number of definitions, and most importantly, in undertaking national monitoring programs throughout the Mediterranean. We have scales of assessment. We have worked a lot on the scales of assessment, on also identifying threshold values, background information, and a series of elements that they are essential towards assessing GES, non-GES conditions for eutrophication, including guidelines and monitoring protocols and others. Now we'll go into the results of the 2023 MEDQSR. As you may know, this assessment is done at regional level, but we also focus also on the sub-regional and in some cases even bigger zoom level. For this assessment, we used comparative assessments. Also, we used assessment tools like the NEAT and the CHASE, and we provided a coherent and quite comprehensive approach on the status of eutrophication in the Mediterranean. By the way, I would like to note that this report was endorsed by the Mediterranean countries recently in December 2023 in Porto Rose in Slovenia during COP23. And very soon we expect to have the website available. Here are some extracts from this big report. In the Adriatic sub-region, the use of the NEAT revealed that many or all the stations achieve GES conditions. These are the blue and green colored cells. Then we have the Levantine and the Aegean Sea, the Levantine sub-region, the Aegean Sea, where we have also 1 out of 18 assessments unit is not in good status, whereas the rest are in good status. We also used information from literature for several specific areas in the region, and the assessment result shows that 2 out of 16 assessment units are primarily found in non-good status, especially for the Aegean Sea. Then I will focus a bit on the Central Mediterranean sub-region, where the assessment results shows 7 out of 36 assessment units are likely in non-good status. So again, a situation where quite many stations are in non-good status, non-good GES status, in the Abrakian Gulf and some other, in the Gulf of Patras and some other places like the Gulf of Gabes, etc. This is a bit of some extract about the Western Mediterranean sub-region, where you can see that also the situation differs from the central Western Mediterranean towards the Alboran Sea, towards the southern parts, again with let's say few stations being in GES and some others in non-good GES. And as I've explained to you, we have the full report available, which can already be shared with you in the online format. And very, very soon in the coming weeks, we also expect to have the website available, so that a product that can be easily accessible by all of you. I would like to thank you very much. I would like to thank HCMR for the invitation, and I hope I passed the message. Thank you.
Thank you, Christo. It appears that despite the conditions of climate change, some part of the sea at least is under good environmental status, and I hope we will figure out how to continue on that. So let's continue with the presentation on the impact on marine fisheries and aquaculture. And our speaker is Dr. Dimitris Damalas, supported in the preparation by Nikos Papandroulakis. You have the floor in 7 minutes.
Okay, hello from me as well. I'm Dimitris Damalas. I will be presenting the impacts of climate change on marine fisheries and on behalf of Nikos Papandroulakis on marine aquaculture, with a special focus on the Eastern Mediterranean. So, for aquaculture, it's been projected that by the end of the century, temperatures will increase up to 7 degrees centigrade, and we will have an intensification of heat waves. Temperature, as we know, affects physiology, metabolism, and behavior of fish, and is also accountable for numerous other things that more or less were listed by our moderator. So the need to assess all these risks is quite urgent, and to do so we have to understand the responses of organisms to heat stress and, of course, develop appropriate tools. Marine aquaculture in the Eastern Mediterranean is quite significant. Let's say Turkey, Greece, and Egypt alone are responsible for almost 3/4 of the production of sea bream and sea bass. And Greece in particular has almost 300 farms with revenues of more than 600 million euros per year. Now, to predict the climate change effects on aquaculture, experimental work is ongoing, which focuses on defining thermal tolerance of specific species under study, and predictive modeling through dynamic exchange budget models is ongoing to study the effects of temperature and extreme events in 9 different regions of Greece, both inshore and offshore, up to the mid of the century. So some results so far show that for specific species, let's say like meager, the situation is could be considered beneficial, as increased temperature actually leads to faster weight increase, and a 10% increase in biomass may be expected by the mid of the century, while for others, like sea bass, the situation is not as beneficial, and we might expect up to 20% reduction in the biomass in the future production. Now, there's been a series of meetings with stakeholders to identify threats and opportunities of climate change and to discuss adaptive measures. To this end, HCMR has developed in the framework of the project ClimeFish a decision support software where both scientists and the industry can input the species-specific, the species under study, its specifics, let's say the physiological limits and tolerance, and of course, reason on specific climate scenarios in the future. And of course, economic parameters to finally, as output, identify which species is actually worth investing in the future and how will future production be projected. Now, still we have significant knowledge gaps as we focused mainly on the physiological responses to temperature, while many other parameters are out there to be studied, like, let's say, acidification, salinity, algal blooms, and diseases. So it's important to develop adaptation strategies and measures both at national and regional level. Now, passing on to marine fisheries, obviously it's a very important economic activity worldwide. More than 40 million people are actually directly involved, and 4 times this number indirectly, 200,000 of them in the Mediterranean. It's projected that fishery production based on different climate change scenarios is to be reduced between 3 and 12% by the mid of the century. Now, some examples of climate change. One effect is the regime shift. Regime shift is actually a reorganization of the whole ecosystem, which can be attributed also to climate change and fishing as well, generally anthropogenic activities. A very concrete example can be given from the Aegean Sea, when someone in the upper right panel, when we model the environmental stressors against the biological system, meaning species abundance, one can see that the system passed from a quite resilient state in the 60s and 70s to an unbalanced state in the 90s, and then slipped to a quite resilient, steady state in the last decade, where, in a few words, the system passed from cooler water masses dominated by fish to warmer and more acidic warmer masses dominated by cephalopods and crustaceans, while the tipping point in time when the regime shift was identified was the late 80s, early 90s, and this coincides with other regime shifts identified in other marine oceans of the world. Now, another effect of climate change is the establishment of more and more invasive alien species. Let's say on the right upper graph, we can see a heat map of the number of invasive species establishing themselves in the Mediterranean Sea. As you can see, in the Eastern Mediterranean, more than 100 species have established themselves in the past decades. An example from Israel, projecting in the future, Israel has a very big problem in their coastal fisheries, shows that although the invasive species biomass will increase up to the middle of the century and then stabilizes, the total biomass and the total catch of the fishery will actually decrease. This is due to the fact that the native species biomass will decrease as they gradually will be displaced by the invasive species. So the species will have to adapt to climate change, so physiological adaptations have to take places if they want to actually thrive and survive. There is an example from the Ionian Sea where it has been documented that hake has been maturing in a much earlier size than before, almost 5 centimeters less, and this has been very well associated with the environmental regime shift that occurred, but it's also attributed to fishing. And another example for the future is for red porgy in the Aegean Sea. It's projected that after the mid of the century, the water temperatures will exceed the thermal tolerance of the species during the spawning season. So either spawning will fail and the stock will decline, or the species will have to adapt and spawn much earlier in the season. That has already been happening in other species worldwide. Another issue attributed to climate change is the more and more observed jellyfish blooms. Actually, there's a very well-known study which wonders if a Mediterranean Sea full of jellyfish could be a probable future. Actually, jellyfish consume larvae and egg of commercial fish species and actually have a detrimental effect on the stock status. Finally, not just to pass only negative messages, it might be the case, it has to be seen if it's so, that opportunities may rise for the fisheries. Let's say it's projected that at least the Eastern Mediterranean will become mesotrophic from oligotrophic after the mid of the century, meaning waters will be more productive. It's also been documented already, as you can see in the bottom anomaly graphs of various species, that squids, octopus, and shrimps are on the rise in contrast to fish. And of course, some thermophilic fish species like round sardinella or parrotfish are also on the rise. They have benefited from climate change. However, it's to be questioned if we as consumers are actually willing to put new species on our dietary habits. And to conclude, I have to say that climate change has actually been put forward by the scientific community, NGOs and conservation groups. The industry itself do not see climate change as a priority threat. Actually, what they see as a priority threat is energy costs, market volatility, equal opportunities to markets, as they see that the EU is more strict in measures than others and they have unfair competition. So I think you will all more or less agree that if the economic interests exert leverage to the decision makers, they will be more, let's say, influential than actually scientific advice. Okay, thank you very much.
Thank you very much, Dimitris. I have to apologize for the very tight time schedule, but we were 3 suggestions, proposals for side events, and we were condensed in one session. So it was just a few minutes for each one to speak. So the last but not least from our group, Jesse Turner is going to talk about the Ocean Acidification Alliance. Thank you, Jesse. You have 7 minutes.
I'll try to be even more quick than that. How's that? Lovely. Well, thank you so much. It's great to be here. I'll just set a timer so I know how long over 7 minutes I'm going. Just kidding. Great. Well, my name is Jessie Turner. I'm here with a group called the International Alliance to Combat Ocean Acidification. We were actually launched at the third Our Ocean Conference in 2016 in Washington, D.C. by a network of U.S. states, and now have grown to multiple national governments, state, tribal, First Nation, ports, working together to think about our unique approach to addressing climate-ocean impacts, by which we mean warming, ocean acidification, and oxygen loss, which we have been talking about already today. And so I'm not really going to give an OA science talk. My slides are very different. And so I'm just going to quickly say, I think we've heard in the intro, the global ocean has absorbed 30% of CO2 emissions. Since the beginning of the Industrial Revolution, that's caused a 30% increase in acidity from pre-industrial levels. 93% of excess heat has been absorbed, leading to increased temperatures, stratification, circulation changes, marine heat waves. And also the acidification has direct impacts on a decline in aragonite saturation in our oceans, which really makes it harder for shell-building species they don't have the building blocks that they need to build their shells or skeletons. But cumulatively, all of these impacts, as we've been hearing, really have grave consequences, not just for shell-building species, but also for food webs, ecosystem function, biodiversity, habitat compression, and the urgency hasn't always been there from the political perspective, as our last speaker was saying. So I'm just going to share a little bit about what the OA Alliance is and what we are launching here in Athens. I assume green is forward. Yeah, great. Lovely. So the OA Alliance, as I mentioned, is a collaboration of governments. And when they join the alliance, they commit to creating something called an OA action plan. And that's really a unique document that encompasses actions that they are taking or will be taking to respond to ocean acidification. And this is especially important in our view for achieving climate-resilient fisheries and aquaculture, thinking about climate-smart conservation goals, coastal resilience and habitat restoration efforts, effective upgrades of infrastructure coastally, thinking about wastewater and nutrients and nitrates that are making coastal acidification and hypoxia much worse, and accelerating climate mitigation, adaptation, and resilience near shore. So, one of the things that the Alliance works to do is to work across these international frameworks. There are places, obviously, in the UN system where acidification knowledge to action is continuing to be put forward. So at the UNFCCC, we have something called the Ocean and Climate Dialogue that was created at COP25 and has now been about 4 years in the making. And we're really working to make sure that ocean acidification mitigation, adaptation, research needs, capacity development, and financing is well situated across the UNFCCC for parties' different activities and for leveraging different mechanisms of the UNFCCC to respond to ocean acidification. At the UN Sustainable Development Goal agenda, Goal 14 actually has an OA target to deliver science policy investments that we need to minimize and address the effects of ocean acidification globally, regionally, and locally. That so far has looked like a lot of science. We have a lot of ocean observing systems working on acidification, but we really need to be putting forward the policy and the investments needed to tackle this issue domestically. We have an OA research program now through the UN Decade of Ocean Science, which is a wonderful global program of coordinated OA researchers really working to identify OA science for purpose. So we're really trying to think about which discrete activities, which discrete decisions our policymakers needing, our marine managers making, and what type of OA science is needed to improve those decisions. And then finally, of course, we show up here at the Our Ocean conferences to really drive deeper political commitment for addressing these challenges of climate-ocean change. I mentioned we ask all of our national governments to create an OA action plan, and that is basically their domestic approach for thinking through what they have, what is their inventory of information, what are their knowledge gaps, and what do they need to prioritize based upon their unique vulnerabilities and preferred or sort of more accessible mitigation and adaptation options. Last year at COP28, we decided to really try to accelerate this call for national OA action plans. We have several state, regional, tribal, First Nation governments that have worked on this topic on a policy landscape, but we really need more national governments to stand up and think about their own approach to this work. So at COP28, we launched, we called for national governments to really put forward action plans arriving to the UN Ocean Conference in 2025 and make sure that we can show up not just with a big science agenda and monitoring, but really thinking about the policy, delivering on policy on acidification by UNOC 2025. And so that's why here in Athens, we have launched the OA Action Planning Leadership Circle. And this is really a different type of approach that we're taking to help governments walk through the specific steps that we want them to undertake when they're thinking about their domestic approach. So we want to find a unique approach that's going to work for them. And right now, we're really focusing on 3 core policy frameworks and how ocean acidification information, knowledge gaps, mitigation adaptation can be incorporated across those policies. They are sustainable ocean plans. Many of you have probably heard about those this morning. Many governments are part of the high-level panel on ocean sustainability. And so thinking about how can we provide guidance for acidification aspects to be incorporated across sustainable ocean planning outcomes. The second are NDCs and NAPs under the UNFCCC. I'm sure we're all very familiar with that. So providing some very concrete guidance on how governments can incorporate OA mitigation, adaptation, research needs, financing needs across NDCs and NAPs respectively. And then thirdly, for EU countries, they have a shared something called the Marine Strategy Framework Directive, which really is a shared directive to better understand and evaluate good environmental status of their coastal seas and waters, and making sure that we understand and can make recommendations with regional seas conventions, with the Commission, about how ocean acidification knowledge could be better reported on and reflected and evaluated against some of these descriptors to inform good environmental status. And to get started, we have 4 easy steps. So we're really we've invited 14 member governments to join us. We are going to work with them directly about which policy approach to domestic OA action planning they would prefer, help them take inventory of the information available in their country or region, and accelerating the appropriate mitigation and adaptation measures for where they are and what their current capacities are. Of course, we want to incorporate and align OA aspects across those chosen policies, and then continue to think about ongoing accountability and implementation of this type of work in 2 years, in 5 years, in 10 years. So that is all I have to say about that. I'm not sure if we have Ms. Katerina Steligani with us to provide a few remarks from the ministry. So over to you, Katerina.
Thank you, Jesse. Dear colleagues, we have Mr. Varelidis is here with us. Okay. So, thank you very much for the short presentation. Ms. Steligani, you can come and represent the ministry. Yes. The commitments immediately after. You can start with the commitments yourself. Okay, or Mr. Varelidis, if he wants to take the stand. Please. So the procedure is to make a small round of commitments between the ministry and the speakers, and we will follow up with the next part B.
Good morning, everybody. Familiar faces, colleagues, delegates. Oh, yes, I know. As you know, or you may not know, the word ocean comes from the Greek word okeanos. This is one of the many reasons that we are proudly hosting the 9th Ocean Conference in Greece, and we are welcoming you and thank you for your participation in the conference. And it's my pleasure to participate in this side event. I want to start by stressing that in practice, we tend to forget that the seas, the atmosphere, and the fresh water form an integrated system that provides the foundation of our lives and economy. In reality, we witness many times a systemic gap between marine, freshwater, and atmosphere management, leading many times to insufficient and not coordinated policy development and planning for coastal and marine areas. These side events, I think, give us the opportunity to highlight, I will focus mostly on the ocean acidification, which is a silent but a crucial threat to our marine ecosystems that demands our attention. This threat is often overshadowed and by other environmental concerns, but its consequences and impacts are profound and far-reaching. For example, consequences like weakened coral reefs, disrupted marine food chain, and diminished biodiversity. Moreover, it is known that the impacts of acidification extend beyond the oceans. Acid rain, for example, as a byproduct of industrial emissions, can devastate terrestrial ecosystems, leaching essential nutrients from soil, damaging forests, and contaminating fresh waters. In this regard, first and foremost, we must acknowledge the urgency of the situation and take decisive action to reduce our carbon emissions. Transitioning to renewable energy sources, investing in carbon capture and storage technologies, implementing sustainable land use practices are just a few steps that we can take to mitigate the drivers of acidification. As Greece strongly believes in cooperation and, where possible, joint action, we commit to join the Ocean Acidification Alliance, and we hope that the 9th Ocean Conference will contribute in the efforts to raise awareness and understanding for the need for achieving marine and coastal resilience in the context of climate change. Thank you very much for your attention.
Thank you very much. You can take the stand. We have used the time of the next group, which is not something that I was hoping for. So I will stop the session here. I just want to make a small announcement that has to do with the commitments of the government. In the webpage of the conference, it has been announced that the Hellenic Center for Marine Research has taken the commitment to, let's say, use its resources and the money coming from the Resilience Fund to support the savior of the oceans. And this sums up to a figure that is more than 16 million euros for the next couple of years. And most of the work have to do with infrastructure, improvement of the infrastructure, and new buildings and new laboratories that will be all in support of the salvation of the ocean. So we thank the government. We will work ourselves. We will work as scientists, as individualities, as citizens towards a better future. Thank you very much. And I'm sorry, guys, we're going to have to quit the discussion. Thank you.